everything we're doing is also on a quiz next Friday. Okay. Yellow packet, no. These exact kind of questions aren't necessarily on there. Okay. Anybody else? All right. So just a basic probability review this morning real quick. Eventually, we're going to have to know probability and odds, independent and dependent events, and how to find the probability, list of sample space, number of possible ways an event can occur, whether we use combinations or permutations, and counting principle. That we're not getting to those today. Trying to break this down a little bit. Oh, I did want to remind you real quick that there is stuff expiring Friday. Okay. I printed the list for you last week, I think, before break, right? It's 5.3a, b, 5.4, and 5.5, the last of the trig stuff. So please double check. Okay. All right, today, basic probability, we can talk about experimental or theoretical. If I ask you, you know, what's the probability that you roll a 2 on a die, you would tell me 1 out of 6, and that's a theoretical probability because you haven't actually done anything. So it's just the number of favorable outcomes over the number of total possible outcomes. So this is kind of in theory what should happen when you haven't done an experiment and you want to put number of favorable outcomes over possible outcomes. So if you're going to say, I want to roll what's the probability that I'm going to roll a 2 on a die, assuming it's a 6-sided die, you would say it's 1 out of 6 ways the die could land would have a 2 on it. Any questions about that kind? Experimental probability is the probability after you have done an experiment. For example, over here, it says the number of times an event occurred over the number of trials. So I don't even know what this spinner looks like, but if I asked what's the probability of spinning an X, well, 4 times it landed on an X out of a total of 20. Is that right, guys? Did I add those up right? Or 1 in 5. Okay. Now, the spinner may look like this. And it may be that in theory, it's roughly 1/3 of the spinner has an X on it. But our experiment showed that 4 out of 20 times it actually landed on an X. Everybody understand the difference between theoretical and experimental? Okay. The only way you can ever calculate is experimental is if I give you some kind of data to use. All right. So what's the probability of choosing a girl from the students in our class? 2, 3, 4, 5, 6, 7, 8, 9 girls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18 total students. So 9 out of 18, or okay. And I don't care if you use a decimal or a fraction. I'm not going to be picky. Okay. Xander, this is for you at 10. Something about must see at 10. So yeah. All right. How many of you are not familiar with a deck of cards? I always hesitate to ask deck of cards questions just because everybody pretty familiar with what a deck of cards has? Okay, so there's 52 cards. You have ace, 2 through 10, jack, queen, and king. That's supposed to be a Q, sorry. And there's 4 suits. There's red hearts and diamonds. And then there's black spades and clubs, but I would never ask you specifically the difference between those. I know some people just have a hard time. Okay. So what's the probability of drawing a red card out of an entire deck of cards? Half of them are red, right? Are we good? How many of them are hearts? It's actually 13 of each of these. Okay. So 13 out of 52 or 1/4. Does that make sense, guys? 1/4 of them are red. Yes. Because all of the diamonds and hearts, so there's 26 out of 52. You good? A red 7. How many red 7s are there? Yes, out of 52 or 126. You should reduce if you can. I think it's easier than doing fraction or decimals. A black heart. Are any of the hearts black? So 0. Yeah, I was gonna say only Miss Hoffbauer's, right? I probably shouldn't draw the line through because I don't usually do that, so it's just 0. Which brings up the idea that probability is a scale from 0 to 1, right? Everybody good? You can have a probability of 0. I just had some here if anybody said they weren't comfortable with what it looked like. All right, so probability can go anywhere from 0 to 1, can't be greater than 1. Rolling a die, show the sample space. So a normal 6-sided 1, 2, 6, just in case. You can list them in any order. I don't know how that happened, but 1 through 6, okay, is the sample space. So what is the probability of rolling a 4? What's the probability of rolling an even number? 3 out of 6 or 1/2. What's the probability of rolling a number greater than 1? Okay, everybody good? Probability of rolling a 7 with a single die would be 0. Okay. No trickiness there. All right. This question is kind of amusing, and you'll see why in a minute when we start listing the possibilities. Every year I think I'm going to change the names, and I don't. It says Bill, John, Sue, and Ann are all up for promotion. Their boss is going to choose a team of 2 people to lead their department. Everyone is equally likely to get the position. Show the possible combinations for the team. Okay, so Bill could be picked to work with John, or Bill could be picked to work with Sue, or Bill could be picked to work with Ann. Anybody feel like giggling quite yet? All right, John could be picked to work with Sue, or John could be picked to work with Ann. Sue could be picked to work with Ann. Is that all the possibilities, guys? Because reversing them doesn't change anything, right? Still the same 2 people. So how many possible ways are there that this could happen? What'd you say? Okay, wait a minute. There's choosing a 2. How many different teams of 2 are there? That's 6, right? Okay. 6 different teams of 2 are possible. Does everybody see what I did? I just did Bill with each of these, and then John with the 2 remaining, and then Sue with the 1 remaining. You could list them in any order you want. What is the chance that Bill and Sue get the promotion? Yes. What is the chance the team is made up of 2 men? Assuming the names are gender specific, we'd have Bill and John is the only one with 2 men, right? That Ann is one of the people getting the promotion. So how many of the teams contain Ann? Everybody good? All right, this question gets far more complicated. It says a couple is planning, I think that should say on having 4 children. Write out the possible outcomes. Remember, birth order would constitute a different outcome. So you could do a tree diagram. Does this look like great fun? Okay, so it has girls are blue and boys are red, just to confuse me. But it says the first child, you could have blue or red. And then the second child, well, if you had a red, you could get a blue, or you could had a blue and get a red, etc. Okay. I actually listed all the possibilities here. You could have boy, 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 girl, boy, boy. So all of this was all boys. This was 1 girl, and I moved it in different spots. This is 2 girls, and I moved them in different spots. Okay. And this is all girls or 3 girls and 1 boy, and I moved them in different spots. All right, so how many different ways could that happen? 16 different ways, right? No, because it's not 4 times 4. Does anybody know what it is? I mean, it is in essence, but it's 4 different ways, 4 different kids you're having, and each time there's 2 outcomes, okay? So that's where the 16 comes from. But in all girls, we could have figured out was 1 out of the 16, right? And all boys is 1 out of the 16. At least 1 boy, yes, because the only thing that doesn't have at least 1 boy would be the all girls, right? Now, if you had read those 3 questions, there would really be no point to listing all this out unless it asked you to, right? Because this doesn't ask anything like, what's the probability the 3rd child is a girl? That gets more complicated, but it didn't ask anything like that. All right, no questions there? All right, real quick overview of the probability rules. Then the probability of an event is written like this. That's why I tried to write in the beginning like the probability of rolling a 6. Remember, I just tried to write it like that to practice that's what that means. The probability of an event is always between 0 and 1. The closer to 1 the probability is, the more likely the event is. The sum of all the probabilities of a sample space is 1. Do you know what that means? Like if you figured out the chance of rolling, the sample space for the die was 1 through 6, right? If you add up the probability of rolling a 1, a 2, a 3, a 4, a 5, and a 6, those all have to add up to 1. 1, 6 plus 1, 6 plus 1, 6. We good? It always has to total 1 because if you've encountered all the sum of all the probabilities of all the outcomes, it's got to add up to 1. Makes sense. The probability of an event not occurring then is 1 minus the probability of the event. Okay. So basically, if I say the probability of rain today is 0.8, what's the probability of no rain? 1 minus 0.8 or 0.2. Everybody good? It's just 1 minus. Okay. If the probability of an event occurring is 3 out of 5, what's the probability that it does not occur? 1 minus 3/5 would be, are we good? Some of you are like, fraction. All right. Compound events are when you're talking about multiple things happening. There are 2 possibilities. There are independent events or dependent events. Independent events are when you say something like, I'm going to draw a marble out and flip a coin, or I'm going to spin a spinner and flip a coin. They don't have anything to do with each other, right? That one does not affect the other. Those are independent events. So if you roll a die and flip a coin, what is the probability that you roll a 5 and then flip a tail? Up here it says when you want these things to happen, if they're independent, you just multiply them. So to roll a 5 would be 1 out of 6. And to flip a tail would be 1 out of 2. So the probability is 1 out of 12. Any questions about that? You just multiply the probabilities together. If you roll a pair of dice, what is the probability you will roll a pair of 3s? So the first dice has a chance of getting a 3 is 1 out of 6. The second dice, the chance of getting a 3 is 1 out of 6. So if you multiply them, you get 1 out of 36. Because what one die lands does not affect the other die, right? Okay. If we listed all the ways 2 die could land, we could get a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, da 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 da. There's 36 different ways. Okay. And 3 and a 3 would only be one of those 36. All right. This example is a little more complicated. We got to think about this. The chance you pass test A is 40%. The chance that you pass test B is only 20%. Yikes. Note that the tests are independent of each other. So what is the percent chance of failing A? Yes. Everybody good? Pass A was 40, fail A was 60. Okay. You pass B is only 20. So what's the percent chance that you fail B? 80. Now, if these are two totally separate tests, okay, one's English and one's math, they're not related, what's the chance that you fail A and fail B? They're independent events, so you're just multiplying the probabilities. Fail A was 60 and fail B was 80, so 48, yes? Okay, pass A is 40, fail B is 80, so what is that? I'm getting 32. Anybody else getting 32? Okay, fail A, pass B. Tell me what to multiply. All right, and pass A, pass B. Yeah, 0.40 times 0.20. I don't know what just happened to my cursor here. Is that 0.08? Okay, so what do those all add up to? Well, this would be 20, and these two add up to 80, so it's 100, right? 1 or 100%. That's because we covered all the possibilities, right? There's only 2 tests. So pass one, fail them both, pass them both. Those are the only 4 possibilities. Any questions? All right. It was important that it said these are independent of each other. All right. Dependent events are usually things you talk about like without replacement. Okay. What's the chance that I draw a jack? I don't put the card back. And then what's the chance I draw another jack? Do you see that those are related to each other? They're, because you've taken a card out of the deck, right? So the probability changes for the second event. So for the probability of things happening twice, the chance you get probability of A and B, you do the probability of A times the probability of B given that A has occurred, or B times A given that B has occurred. That sounds really crazy. You just think about the probability of each event and multiply them. Okay, multiply in here. So if you have a deck of cards, what's the probability that you pull 2 aces in a row, and that's without replacement? Okay, so the first chance you get an ace, how many aces are there? 4. Out of, okay, notice then it says you multiply by the probability, assuming that you won the first time. It's always given that you won the first time. So if we got an ace, how many are left? 3. Out of now Everybody good? Okay, those both reduce. You can type it in your calculator and they'll reduce. This is 1 out of 13 and this is 1 out of 17. So I don't know what that is. 1 out of 391. I'm just making up a number. 220. 221. I just knew it ended in a 1, so I was totally guessing. Any questions on how we did that? All right. Example 2 says if we have 30 students in class and 17 are boys or 13 are girls, we're going to pick a president and a vice president. So they can't be the same person. Okay. What is the probability of having a female president and a female vice president? So the first time we go to pick for a president, it doesn't matter which we do first. There are 13 girls to pick from out of a total of 30 students. But if we did successfully pick a girl the first time, what is the chance that we go back and pick another girl if it's totally random? Out of 29, because you can't be both. Yep. I'm just going to let you do that on the calculator. What does that reduce to? This would go in here. I don't have a calculator, guys. Someone else get that? See, 6 would go in here 2 times and 6 would go in here 5 times. So that seems right. Yes. Okay. It is. We could, that one you might want to just quote as a decimal just because it would make more sense if we were looking at it, but it doesn't matter. All right. Now it's going to talk about things that are mutually exclusive. So the probability of unions, if you have an or, what's the probability A or B happens? Is the probability of A happening plus the probability of B happening minus the probability that they both happen. I don't ever think about it that way. I just think about, it says, from a deck of cards, what's the probability of pulling a red or a 2? I just think about how many cards are winners over how many cards there are total. So these are, what it's talking about though is or questions, okay? I win if I get a red card, which there are 26 of, right? Or a 2. Now, there are only 2 more 2s because there were 2 of them that were red. That's how I think of it. What they're saying is you could say there's 26 red cards, there's 4 2s, but I have to take off the 2 that overlapped. I just usually don't think about it that way, but is everybody okay one way or the other? So there's a total of 28 winners out of 52 cards, which would reduce by 4 to 7/13. How did I do? Okay. If we're rolling a die, what is the probability of rolling a 6 or a 3? Okay. So this is saying I win if I get a 6 or a 3. So I have 2 out of 6 different ways that I'm a winner, or 1 out of 3. Everybody good? Would that have confused you on a quiz? Okay, what is the probability of rolling a 6 or an even number? Now you got to be careful because they're trying to trick you, right? Yeah, 2, 4, and 6 are the only winners. So it's 3 out of 6 or 1/2. Good luck. Everybody good? All right. I was maybe going to stop there for today. Is that okay with everybody? Except I think I assigned some work on odds, and we didn't talk about odds today, did we? So real quick, I need to talk about odds. I think odds are actually defined at the top of worksheet 3, maybe. Let me find my packet. The top of worksheet 3, it says odds are defined as winners. That's how I think of it anyway. to losers. You definitely can still write them as a fraction. Its actual definition is number of possible outcomes favorable. Try that again. To number of unfavorable. Ugh. Just give up, Hofbauer. I always write them with a colon because my brain needs to be thinking differently between odds and probability. So it just helps me if I write fractions for probability and odds with a colon. You can write them either way, but so for example, if we were rolling a die, what's the odds that you roll a 2? No. 1, 2, no. The odds of rolling a 2 are 1 to 5 because it's winners to losers. It's not probability. Odds are where probability is winners over total possible. Odds are winners to losers. So what's the chance that I draw a heart if I want the odds that I draw a heart? There's 13 hearts. Yes. So there's 1 heart for every 3 that are other, right? Everybody okay on odds? Need me to do more? There aren't any questions about like the odds of multiple events or anything. It's just straight up single event. I mean, I could say, I suppose, what are the odds of drawing a 6 or a 4? So there would be 8 winners. And what would that leave? 44 losers? Okay, something like that. Any questions on probability or odds? All right, I'm going to stop there today then, and then we're going to look at the yellow packet. All right.